So let us understand, children, the working of DC electric motor, right? What exactly is a motor? A motor is a device which converts electrical energy into mechanical energy. For example, when electric current goes into a fan, the fan begins to rotate because a fan is a motor, right? When electrical energy goes into a mixer grinder, the blades of mixer grinder begin to rotate. So mixer grinder is nothing but a motor, right? Not only this, the electric trains, the local trains we call them, right, is also a motor. Because when current flows through that particular trains, the wheels of the trains begin to rotate, right? So what is motor? A device which converts electrical energy into mechanical energy. To understand motor, children, we have to remember three basics. We require three very basic components. The first thing is we should know Fleming's left hand rule. And I think you all know what is Fleming's left hand rule. So what is left hand rule? Stretch your thumb, the forefinger and the central finger of your left hand mutually perpendicular to each other. If the forefinger shows a direction of magnetic field, the central finger shows a direction of current, then the thumb is going to show the direction of motion of the conductor, right? One more thing I told you was if the motion is upwards, the current is outwards. And the third thing I asked you all to remember was something called inertia, right? Now since you know the basics, let us see how a DC electric motor works. The first part of a DC electric motor is a rectangular iron slab, and this rectangular iron slab is called as iron core, right? This iron core has a winding. There's a copper wire which is wound on this particular iron core, and this winding of copper wire is called as armature coil, right? Below this, on both sides, if I call this as armature coil as A, B, C, D, on both sides of the armature coil, you have two pole pieces of a magnet. Now this is a north pole, so that side has to be a south pole. This is a south pole, that side has to be a north pole. So either you can use pole pieces of a magnet or you can use a horseshoe shaped magnet, with only the poles kept apart, right? Now here we have pole piece of a magnet. Now let us come below. What we have next is this particular device, this particular part, component, which is called as a split ring, a commutator, right? You take one metal ring, and this metal ring, you cut it from the center, you will get two parts, and this two parts is called split ring. A split ring is also commutator, right? Commutator means with interchanger, something that goes from one place to another, right? So this split ring also is supposed to go from one place to another. Let us see where. This particular split rings are called R1 and R2. This R1 and R2 are connected to two brushes, carbon brushes B1 and B2. These carbon brushes are connected to a battery. So we have this battery, right? These are the different components of DC electric motor. Now let us see how a motor works. To make this particular motor work, we have to pass current through it. So let's pass the current. As soon as the current flows through it, the current will flow from B2, the current will go into R2, from R2 the current will go to D, from D it will go to C, to B and A, right? Now when the current is going from D to C, the current is going inwards. When the current is coming from B to A, the current is coming outwards. When the current is outwards, the motion is upwards. So AB is going to move upwards, and opposite side CD is going to move downwards. If both the motion is equal and opposite, then this will begin to rotate in a clockwise direction. So as it moves in a clockwise direction, rotating, it comes to one central position, and in the central position the connection between the commutator and the brushes is lost. When the connection between the commutator and brushes is lost, connection is lost, current will not flow. But the armature coil will not stop, it will continue to rotate because of inertia, right? So it continues to rotate, and once again the commutator is going to touch the brushes, and once again the current will flow. Now this time the current is going to flow from B2, it is going to go to R1, from here to A, to B, to C and D. The current going from A to B is going inwards. The current coming from C to D is coming outwards. So CD will move upwards and AB will move downwards, and the process will continue and the rotation will also continue. Once again, as it is rotating, it will come to a vertical position, and we know in vertical position connection breaks, but it will not stop because of inertia. It will continue to rotate, and once again the commutator will touch the brushes. Now once again when the commutator is touching the brushes, once again the current will flow from B2 to R2 to D to C to B and A. And the side AB will once again move upwards, CD will move downwards, and this rotation will continue and the story is going to continue. And that's how the motor works, right? Children, we have seen the working of an electric motor, but it is also important to learn the answer. So we are going to learn the same answer of the working of an electric motor with the help of a flow chart. Firstly, what is an electric motor? Right? It is defined as a device which converts electrical energy into mechanical energy is called an electric motor. Right? What are the parts of a motor? The first part is called armature coil. What is an armature coil? A large number of insulated copper wire which is wound on an iron core in a rectangular shape. That means you take a rectangular shape iron core and on that you wind copper wire which is insulated, right? That is an armature coil. The next is strong magnets. You can say pole pieces of a magnet, or you can use a horseshoe magnet whose poles come around the armature coil, right? The next part is a split ring commutator, right? Now when it comes to a split ring, what is a split ring? A ring which is cut from the center, right? Splitting it into two halves, right? So it consists of two halves, R1 and R2 of a metallic ring. Commutator reverses the direction of current. Now what does it mean? When I was explaining the working of the motor, first time when the motor was working, the current was flowing from D, C, B, A, right? But as the armature coil rotates, in the second half, the current was flowing from A, B, C, D. So in the armature coil, the direction of current is reversed. Why? It is reversed because of the split ring commutator. Had we not had a split ring commutator, the direction of current would have not reversed and the running of motor would not have been proper, right? Okay, we come to the next part, and this is brushes. There are two carbon brushes, B1 and B2, which is used to press or touch the split rings or the commutator. Now coming to the working. As soon as the current flows through ABCD, the arms AB and CD will experience a force. The arm AB will experience an upward force and CD experiences a downward force. If both these forces are equal and opposite, then the armature coil ABCD will begin to rotate in a clockwise direction. Now when it rotates in a clockwise direction, as it is rotating, it will come to one vertical position. In the vertical position, the contact breaks. But when contact breaks, it will not stop, right? It does not stop because of inertia, right? It continues to rotate. Now when it continues to rotate, it is going to start from 0 degree. From there it is going to go to 90 degree. From 90 it will go to 180 degree, 270 and 360. In 360, one rotation is completed. And again, the same story continues. That means once again, AB goes upwards, CD comes downwards and the story again starts. Again 0 degree, 90 degree, 180 degree, 270, 360, and once again the same story. In this way, the armature coil continues to rotate and the motor works.